Hello, everybody. I hope you're having a wonderful Thursday. My name is Craig, and I'm a fifth-year graduate student in the Department of Chemistry and Biochemistry, and I'm a NFCDS Pedagogy Fellow here at the University of Notre Dame. And welcome to a first taste of LaTeX for the curious, where we're going to discuss how to create your first LaTeX document in Overleaf. If you are not familiar with LaTeX in the slightest, do not worry. I have a nice little GitHub repo that everybody can take home with them and practice some more LaTeX on their own. If you've never used LaTeX before, if you've never heard of what LaTeX is before, LaTeX is a high-quality typesetting system or typesetting program used to make very pretty professional-looking documents. It is free, it is cross-platform, so I see a lot of Apple computers, I see a lot of Windows, I see Dell. Whatever operating system you're on, LaTeX works on that operating system. It's often used to create professional-looking documents. So if you're preparing a document for publication, a lot of people will write in Microsoft Word or LaTeX. I've used LaTeX to make all my publications. I've used LaTeX to make my CVs. I've used LaTeX to generate homework assignments when I was a TA. It is very easy to get your hands on LaTeX. So this first option, the LaTeX project, it is open regardless of your operating system. If you go to their website, you can download and you can configure LaTeX on your own if you want to make a little bit more of a customized environment. If you're a real big nerd like me, that might be the way to go. If you have a CRC account here at the university, there's actually preloaded TeX files on your CRC account. You would just activate them by typing module load TeX live. In my research group, these are the two options we generally go for because we have to customize our TeX options. However, growing ever more popular is Overleaf, which is an online, free, cloud-based LaTeX software used to generate TeX documents. And it has been growing and growing in popularity, probably because they've created a lot more interfaces with GitHub and Dropbox, making it quite easy to use. So those are my little couple PowerPoints. Now comes the fun stuff. We're actually going to jump into our little workshop. So if, by a show of hands, who here has never used GitHub before? 2. OK, awesome. GitHub is quite easy. We're not going to go into how to use GitHub today. I'm essentially using GitHub just like a website. So I don't know if everybody can see this. If you could just go to this website, github.com/cwait, which is my username, /LaTeX workshop, or you just go to Google and type GitHub cwait LaTeX workshop. It should take you to my LaTeX workshop repo, which I'm essentially using as a website in order to walk through this workshop and how to use LaTeX. This way you don't have a couple of papers that you have to lug around with you everywhere. All right, so I'm going to just wait a couple of minutes to give everyone a chance to get to this GitHub repo. While you're getting there, I'm just going to very quickly go over the learning objectives of this workshop. So if you've never created an Overleaf account, we're going to go through the steps on making an Overleaf account. Then we're going to talk about what every LaTeX document needs, which is a preamble and a body. A preamble is the part of the LaTeX document that you use to specify what kind of document you want to make and how you want it formatted. And then the body is where you put all of your content. We're going to purposefully make some errors to show what the error messages are and give you a chance to fix them. And then we're going to go through some commonly used LaTeX commands, how to write mathematical formulas, creating tables, and inserting figures. And then, depending on time, we'll go through some of these more advanced topics, how to create chemical formulas, or how to create citations. So is there anybody not on the GitHub repo? OK, awesome. So who here has never used Overleaf before? Raise your hand. OK, so we're going to take some steps to creating an Overleaf account. If you already have an Overleaf account, you could just open up a new tab and log into your Overleaf account. If you've never made an Overleaf account, we'll just go through these steps right here. So Overleaf is increasingly popular, mainly because you're able to collaborate with other people on GitHub, on Overleaf. So for example, I'm working with a couple of collaborators on a paper we're working with, and we're all able to work in the same Overleaf document and collaborate together. There is synchronization with Dropbox and GitHub. There's also ways to import citations from Zotero and Mendeley. And there's history documentation. Everyone here has a Notre Dame account. If you register with your Notre Dame credentials, you'll get all of these fun things without having to pay for them. So let's get started. So we can go to Overleaf. If you click these links in GitHub, they'll overwrite whatever tab you're in. So I recommend if there's any link that you want to click, you just right-click and open in a new tab. So we'll go to Overleaf. I'm going to log in. If you don't have an Overleaf account, at the top right-hand corner, there should be a register button. Go ahead and press that. And then use your Notre Dame credentials to register your Overleaf account. Do not click login through your institution at the bottom. Just register by using your Notre Dame email and then a password. And then once prompted, it'll ask you to create your first project. So you can click this green button here, create your first project. And then I will show you what to do in a second. So let me just log in. There we go. OK, if this is your first time, if this is your first time creating an Overleaf project, it'll probably ask you for a project name. Just type something and hit test. And you'll see a blank document that looks like this. Just click this back button to get to the main menu. So everybody should be here. I'm just going to delete this. So everybody should be here. If this is your first time creating an Overleaf project, it'll look a little bit emptier than mine. Does anybody not have their Overleaf account registered or set up yet and is not at this main menu? OK, great. So this is your workspace. This is your project management space. If this is your first time in Overleaf, you won't see anything in here. If you've made an Overleaf account and you have some files, they should be in here. Overleaf is actually really nice. So you can create projects and share them with other people. You can control those types of projects here. You can also create folders and organize your project. So for example, if I want to see all the projects that I've listed under homework where I've created a homework assignment, I can click there and just look at those particular types of homeworks. Let's start off by creating a new LaTeX project. This is what we would do every time when we want to start a new project. If you go up here and click New Project, Blank Project, it'll generate an empty file for you. Let's say I wanted to make a CV and I wanted to start off with a template. I can actually come down here to Resume and CV and browse through some of the pre-generated templates where I would just fill in my information. That's actually very, very handy if you want to make very professional looking documents. Some people have spent a lot of time generating those templates. Today, we're just going to start off with a blank project. And we're going to give it a name. We are going to call it, did I decide what name we're going to call it? My first LaTeX project. And then create. And it should generate a window like this with the title of your first project, your name, and then the date. There are 3 windows. I'm going to blow this up a little bit more. Let me go back a little bit. There are 3 windows in your LaTeX file, and this is your general workspace. Your left window is a view of all the folders and files associated with this particular topic. So let's say you had a folder that had a bunch of images. You could put them there on the left and store all your images and refer to those later. If you had several tech documents, so if I had a main.tech and a main2.tech, that contained different informations, I would store that information there all on the left. So your left window is just sort of an organization scheme for your current project. The center window is where you're going to spend 98% of your time. That is the content. So this is where we set up our preamble for our LaTeX document and where we insert all the content into our body. The window on the right is the exported PDF. So you'll notice here on the right of my LaTeX document, I have a recompile button. Let's say I change the name of the title to my first project, and I get rid of the words LaTeX, my first project. I could hit the recompile button, and it'll change the content of the PDF, and it'll export the PDF here on the right for you to download or print. Just a word of warning, I click this little down arrow. I think by default it turns auto compilation on. That generally just slows things down, so I turn them off. If you're writing drafts, you can also change some of these settings to compile a little bit quicker, but that's for you to configure. I just generally turn off the auto compilation off. But every time you want to see what the PDF looks like, you just hit the recompile button here. Okay, are there any questions before we proceed into the fun stuff of actually creating a LaTeX document? Okay, so Overleaf color codes LaTeX commands. So you'll notice we have a couple of blue lines here, green lines. The blue stands for LaTeX commands, and you'll notice that most of those commands start with a slash. So slash document class is a command used to specify what kind of PDF you want to compile. If I don't want to make an article and I want to make a book, I would just change that to book, and that's a special type of formatting that it would do. But let's just keep that as an article for now. Whoops, my first. Options are listed in green. We'll get into what options are in a little bit. And then regular text is written in black. Overleaf also tells you if you made any spelling mistakes, so it thinks it spelled my last name wrong, so it's highlighted it in red. Everything from document class to date is your preamble. This is where we set up and define the way we want LaTeX to format our document. Everything between the begin document and end document is our body, and that's where we put the content of what we want to write. So let's go and set up our preamble first. So here, I just discussed the difference between the preamble and the body. In this section, we'll talk about how to create comments in your LaTeX code, how to import modules to do different things in LaTeX, and we'll begin setting up the content of the body. Okay? So your preamble should look something like this. It's pretty small. There are 5 lines in this current preamble. So the document article is telling LaTeX what kind of document we're creating. We can create a book, we can create a report, letters. That all just dictates how that PDF is going to be formatted in the end. We have this use package, bracket, and then squiggly bracket. In LaTeX, you will often be importing, depending on your project, 10, 15, 20 different types of packages that allow you to do different things. And so I have a set of packages that we'll import in a few minutes. The square brackets are options. These vary from package to package. If you don't know what a particular package does, Google is often your best friend. You could just Google what this package does and what sort of options there are. This particular package, this input ENC, allows you to write special characters that aren't necessarily on the keyboard. We're using the UTF-8 option to say, hey, if I want to write a caret over a particular letter, you'll just let me use the UTF-8 commands in order to generate that particular symbol. Author is my name, and then the date is the current date. Those are just pre-generatedly filled when you start a LaTeX session. Okay, so what we're going to do is we're going to update our preamble to look a little bit nicer. So one of the reasons why I chose to do this in GitHub is you can easily copy and paste code from GitHub into LaTeX. So if you notice here, there's a little section here that allows you to copy and paste code. I highly recommend you do that this way. You don't accidentally type anything in incorrectly. So what we're going to do is we're just going to copy this chunk of code. We're going to go back to our LaTeX project. And everything that I've just highlighted here, so from the document class to the date, we're just going to delete, and we're going to paste in our preamble. And I'm just going to very briefly go over what we've updated in the preamble. So we originally just had document class article. I wanted 12-point font, and I wanted LaTeX to know that I'm going to be generating this on standard letter paper. So I added the options, 12 points in letter paper. And then, just as a reminder for myself or anybody who's going to read our LaTeX document, I put a little comment at the end. Comments are specified by the % symbol. So this tells us what kind of document do we want to create, and what font size and margins do we want to use on our paper. I kept that package, the input ENC package, and I've added 3 more packages here. I have the use package AMS math, which allows us to type useful math symbols and allows us to create fractions in our document. Tablar X, which allows us to create tables in our document. And if you are a chemist or a chemical engineer, which I know many people in this room are, this package is very helpful. This allows you to generate chemicals and reactions very quickly. And then I've updated the title of my project to Hello World. You guys can update your name in the author section and then the date as well. So it's not October, it is February 2022. I've made some changes to this document, so I'm just going to recompile it here. And you see the title's changed. I've updated the date, and then it says introduction. So we've just updated our preamble to specify what kind of document we want and how to set up the formatting of other types of things that we'll add in a second. Great. So I have a little exercise on some of these pages. So this exercise is asking us to add a package that allows us to include figures in your LaTeX document. So I'm going to do this exercise with you guys just so you can see the general idea of how I want the exercises finished. So we're going to add another package that allows us to add figures to our LaTeX document. So Overleaf and LaTeX are very well documented. If there's anything you want to do that you don't know how to do, often someone has written a solution to it somewhere on the web. One of those places is the Overleaf documentation. So if I want to add a package that allows me to add figures and I don't know how to do that, the first place I would personally look is the Overleaf documentation. So I'm just going to open that tab. And it takes me here. And then on the left is the Overleaf guide. So I could search for how to add figures up here. I'm just going to scroll down on the left a little bit to find a place where we can add figures. So figures and tables, inserting images. That's what I want. I'm going to click that, and it's going to take me here. This just briefly describes how to do that. And this is where we add packages to create figures. So I'm going to add the package, use package graphics X, copy, to my LaTeX document. So I'm going to do that right under here. Use package graphics X. The documentation says we need to define a graphics path. This is where we're going to store any images that we make. So I'm just going to copy the graphics path, put that down there. And I'm also going to add a folder here on the left. So I'm going to make a new folder. I'm going to call it images. Create. And that is it. Then we have the begin document, and this tells us how we can actually add figures, but we'll do that later. So I'm just going to hit recompile. Whoops. I'm going to hit recompile. everything seems to work normally, and I'm done. If you need the full solution, you can click here. I'm just going to open that tab. You could just copy and paste the whole thing, or you could see here we are using package graphics X, and then we're setting our graphics path so we can store our pictures somewhere. And that's it. That's all you need to do to set up your preamble. Your preamble takes about 5 minutes to set up, depending on how complicated the project is. You add more packages, fewer packages, depending on what sort of template you're using. If you're making a CV, you'll use other packages, etc. Are there any questions before we move on? Yes?
Do things like capital letters matter?
Do things like capital letters matter? Do you mean like setting your images path?
Yeah, like if it's capital images or lowercase I images.
That's a good question. So here I put a lowercase I images, so my folder must certainly be a lowercase I. If I put a capital I, it won't know where to look. That's a good question. Is there any other questions? All right. Don't need that solution anymore. Next is the body. And so you spend about 5 minutes setting up the preamble. The rest of your time, you're always working in the body. Your body always begins and ends with the begin document and the end document. Anytime you write things outside of those, it won't get generated in your final PDF. Make title is a LaTeX command that's used to read these particular lines, and generate them on your PDF. There's other things you can add, like / affiliation if you wanted to put your university up here. There are other LaTeX commands used to put things up in the title. And then the section introduction starts my first section. If I look back here at my LaTeX window down here, I have a file outline. I have an introduction set up. If, for example, I wanted to make a subsection under introduction, I would do /subsection, and you'll notice as I'm typing, Overleaf is giving me things that it thinks I'm typing, so it thinks I'm typing subsection. I could call this background. I'll make another subsection called methods. And as you'll notice here, my file outline's actually updating. So if, for example, I wanted to go and update the content in my method section, I can just go to the outline, click methods, and it'll take me straight to my methods subsection. So Overleaf is being very clever. It's watching what we're typing. It's organizing what we're typing in order to make navigation move smoothly. I'm just going to recompile quickly. So you see here, it's also numbering our sections. So I'm starting with the introduction section, which is labeled with 1. The subsections get 1.1, 1.2. I can make another subsection. Section. I'll call this blah. Recompile. 1.2.1 is the subsection of methods. If I'm in somewhere in my PDF and I want to see where it's written in the code, I could just double click on the PDF and you'll see it's sending me to background. Yep?
How many levels do you have?
That's a good question. I've actually never tested how many levels I have. So let's do subsection. Blah 2. No, so subsection did not work. So you get section, subsection, and subsection. So those are how many levels you have. We'll get into errors in a minute. But if you were looking at this PDF and you wanted to see where the code is, you could just double click, and it'll actually set on the PDF, and it'll send you to where you are in the code. If you're somewhere in the code and you want to see where it is in the PDF, you could just highlight that section of the code and click this right arrow, and it'll send you to the section in the PDF that you're looking at. You wouldn't be able to do these things with the other installations of tech. This is only an Overleaf function, which is why Overleaf is sort of starting to dominate the field when writing in LaTeX. OK, I'm just going to delete these subsections that I created. So I'm just going to delete background methods. And I'm just going to recompile again. Great, so I'm back to the introduction. Let's go into identifying errors. So when we make a mistake, how do we know where the mistake is, and how do we fix it? So identifying errors, identifying when you get an error in Overleaf is very, very simple. Here I have a little section that is riddled with some errors. So as a test, let's copy this bit of code. It starts with the section introduction, and it has some text in there. Let's just copy that. I don't need this anymore. And under, let's highlight that section and delete that and paste. So just make sure you're pasting this in between the begin document and the end document. And you'll notice immediately when you post it, Overleaf is going to highlight things in yellow for you, and it's giving me a little bit of a warning here. This warning is telling me that something's wrong. If I hover over there, it says unclosed open group squiggly bracket found at end document. This is telling me I forgot to close things with brackets like I did up here. There's an unclosed squiggly bracket. Bless you. If I hit compile or recompile without fixing any errors, LaTeX is telling me, uh-oh, there's an error. I can look at this log output, and it's going to give me a long explanation of what the error is. I can also hover over there, and it tells me what an abbreviated version of what the error is. This error is telling me that I am missing a squiggly bracket. Let's open up that again. Error LaTeX file not found. Yes, this is telling me. That something's wrong. Sometimes these LaTeX errors are not the most easiest to decrypt, and so you can sometimes jump to Google, and it'll help you out. I know one of the errors is that there is a squiggly bracket missing. And so what I'm going to do here is I'm just going to close this with a squiggly bracket, and then recompile. Great, so my X moved from up here to down here. And here it says the error is, in this tutorial, we will be discussing how to write mathematical equations, tables, and how to use /include graphic commands, is what I wanted to type. If you look here, I'm going to make this a little bit bigger. If you look here on the right, it says, in this tutorial, we will discuss how to write mathematical equations, tables, and how to use the something command. It didn't actually write the include graphics command. The reason why it didn't do that is because this is being read as a LaTeX command, but I don't want that to be read as a LaTeX command. I want that to be read as text. So I'm going to change this to say /backslash. This is going to tell LaTeX that I don't want to, that I want the actual backslash to be written. And I'll recompile that. And it's not perfect yet. It's not perfect yet because there are these squiggly brackets are special reserve symbols. Reserve symbols mean that LaTeX will interpret them a little bit differently from text. So if I want these to show up as text, I should use the backslash. So backslash squiggly, backslash squiggly, and then recompile. Did I do that right? Backslash squiggly, include graphics. Yes. I'm just going to copy and paste this from my Overleaf into this here. Oh, that's what I did wrong. I used this backslash command. I meant to use the text backslash command. There we go. That looks much better. So here, what I did is I got a couple of errors that were showing up. I hovered over those errors or clicked on the log file in order to interpret them, and then I went back and fixed them. There are errors and warnings in LaTeX. Errors must be resolved before continuing. Those are the red X's that pop up. Warnings are things that you should fix but are not required to fix. So for example, if I didn't put the closed squiggly bracket here, I got a warning. LaTeX is telling me there's an unclosed squiggly bracket. I think you meant to put the unclosed squiggly bracket here, so when you recompile it, I'm going to fix that for you. So it's going to fix it in the code for you, but you should go back and fix that yourself. And then as I mentioned before, there are protected symbols, so you'll come across them. If you wanted to type the squiggly bracket in text, you actually need to precede it with a backslash squiggly bracket. If you actually wanted to type the backslash in text, you would have to write /text backslash. I have somewhere in the Overleaf documentation what the protected symbols are. We'll see some other protected symbols as we go along. Essentially, if you ever wanted to type a protected symbol and you don't know how to, you could just go to the Overleaf documentation. It'll tell you how to actually type out that protected symbol. So fixing or seeing and addressing errors in LaTeX are not necessarily straightforward, but Overleaf makes those pretty straightforward. Next, we're going to get into some fun stuff, which is writing mathematical equations. Does anybody have any questions? All right, let's go forward. So here, we're going to learn the difference between inline and display math mode. If you're reading a research article, sometimes you'll see that there's mathematical symbols actually written in the text, and then you'll also see that there's sometimes mathematical equations written that are sort of their own little paragraphs. Inline is when it's a part of the text, and display is when it's part of its own little paragraph. So we'll look at how to write mathematical equations in two different math modes, how to initiate them in both math modes, and we're going to get practice in them. Inline math mode, there are several ways of starting an inline math mode session. Depending on your preference, you choose your favorite. So you could start inline math mode by a backslash parenthesis, and you can close inline math mode by backslash parenthesis. You can encapsulate your mathematical equation within dollar signs. That's my personal preference. Or you could do a begin math and then put your equation in there and your end math. Like I said, I use the dollar signs just because they're smaller and easier to use. Since I'm not using the, but you don't have to use the dollar sign. So here I have an example of inline math mode. So what I'm going to do is I'm just going to copy this chunk of code here, go to my first LaTeX project, and underneath this little paragraph that we have written, I'm just going to paste this new section, which is on math mode, and the subsection, which is inline math mode. And I'm going to hit recompile. And I don't need this stuff right now, so I'm going to make that a little smaller. Okay, so I have a section and a subsection inline math mode. You'll notice that when I initiated my math mode, I get some green text. So in between my dollar sign here, and where's the other dollar sign? Here. So I have a dollar sign here and a dollar sign here. Everything in between those two dollar signs are being interpreted in math mode. This says the Gibbs free energy of formation is written as /delta. The /delta is a LaTeX command which comes from this package. If I didn't upload that, if I didn't add that package, the /delta would mean nothing to LaTeX. So /delta gives me the delta Greek symbol. The caret and the underscore are how we specify whether we want a superscript or a subscript in our math mode. And I've encapsulated everything that I want superscripted within squiggly brackets, and everything that I want in subscript within squiggly brackets. So here, that's delta G, circle, formation, delta H circle formation minus delta S circle formation times T. And so that's compiled here. And so what this has done is it has set up this particular equation to be in the text as an inline text, as an inline math, excuse me. You just got to be very careful to make sure that you appropriately encapsulate what you want in superscripts and subscripts with carets and underscores. There are many, many math symbols that you can use. If you scroll down here and you right-click on this thing here that says list of symbols, these are all the math symbols that you can use in LaTeX if you've loaded the if you loaded this math package or this one here. They're both the same, essentially. You've got Greek letters, special LaTeX symbols, if you want to create fractions, arrows, summation signs, integral signs, operations. A whole list of symbols can be found here to create different type of mathematical equations. Okay, did I compile that? I did. So I've compiled that. Did anybody run into any issues or anybody have any questions about inline math mode? Great. Let me scroll down. Display math mode. This is if you want your own mathematical equations to have their own paragraphs and to be numbered. This will automatically number some mathematical equations for you. So to initiate display math mode, like inline math mode, which is slash parenthesis, you could do slash square bracket, or you can use begin equation, end equation, or begin display math, end display math. Personally, my preference is for begin equation, end equation, so I'll use this as an example. I have another chunk of code here for display math mode. I'm just going to copy the display math mode and put that here underneath this paragraph. Oh, I should mention, at the end of this paragraph, I have a slash slash. That's forcing a paragraph break. So that's a protected set of symbols to tell LaTeX, hey, make this a new paragraph. So I'm going to paste that here. I have a new section called display math. I'm going to recompile. This chunk of code is saying, is essentially writing out what the canonical partition function is. And so if we scroll down a little bit here on the right for our display math mode, it says the canonical partition function can be expressed as this, and it gave me a little number at the end, or it can be expressed as this and gave me a little number at the end. I didn't want this word or to be indented. Every time you start a paragraph, if it's not the first paragraph of a sentence, it gets indented. If it's the first paragraph of a section, it does not get indented in LaTeX. You can control that by using the no indent / indent. So I did not want this or to be given a paragraph, given a new, be given an indent. So I said / no indent. If I delete the no and do / indent, it didn't actually, or just get rid of the indent. Recompile. Oh, it doesn't even, oh, they must have updated that. Yeah, it doesn't get indented. That's fun. All right. You'll notice at the end of this equation here, I assigned a label to it. I gave it the label equation partition function. Right here, that part I have highlighted. If later in the text I wanted to refer to this equation, I could use the /ref command. So for example, we can refer to equations in display math mode later by assigning the label and calling it by typing /ref. So now I can say equation 2. So now I can say equation ref ec part. If, for example, I take this label, which is currently on equation 2, copy, and move this label under here with equation 1. Now I'm going to comment this one out. So all I did is I moved this label from equation 2 to equation 1, and I recompile. You'll notice here it says equation 2, but now it says equation 1. So these labels can actually get attached to specific things within your document, and you can refer to them later, whether it's a table, a figure, an equation, anything. If you give anything a label, it could be a section. You could put subsection, and then that gets a label, and then you can refer to that section later in the document without actually having to type equation 2. It's extremely helpful if you have to move equations around. All right, so are there any questions before we move on? Yes?
Yeah, so if you go to LaTeX, yeah, so in the source code, you are using some indentations. Are they necessary?
So your question is regarding those indentations that I put in there between like the begin equation and end equation. They're not. It's mostly for readability. So some programs require indentations. This does not. So if I get rid of these 2 indentations and recompile, no errors, nothing. It just comes out. I mainly just indent for readability. Any other questions? Okay, so the next few minutes or so, I've got a little exercise for you. So under this little section here that we've just written for our display math mode, I have this little thing here for you to write up. So your goal is to try to reproduce this set of paragraphs, which includes a set of display equations, display math modes, and inline math modes. So you could see this X and Y here are sort of italic. That's how you know math mode was initiated there. So let's take 5 or 10 minutes. You're more than welcome to chat with your neighbors if you get stuck. There's a list of symbols here that you can download, not download, just open up on a new tab, as well as some Overleaf. This is from the Overleaf documentation. Some symbols that you can use that are just built into LaTeX without using a package. However, since we did ASM math, it's just better to use this particular document. But go ahead and try to reproduce this exercise down here, and I will walk around and answer any questions anybody has. Before I walk around, I'll just let you know, this is the Greek letter nu, N-U. These X's and Y's, you'll notice that these X's and Y's are italics. A and B are not italic. That's because I specified these to be in text mode. If you have a mathematical equation and you want it to if you want it to show up in text, use the /text command, and it'll force it to be in text mode and not math mode. What else? Equation 3, so I'm using the labels and the references. And fractions, which is something I didn't show. Fractions can be found in this document here with the /frac command. And you put everything in the numerator in here and the denominator down here. So I'm going to walk around, answer any questions if anybody has any. So we'll take the next 5 or so minutes. If you don't finish the exercise, don't worry about it. But I'll leave this up for about 5 minutes or so. Is there a way to turn on autocorrect? What do you mean?
Like if you're writing MS Word, there's some things that if you make a mistake, they can autocorrect, like actually sentence without.
Oh, that's a good question. I never thought about doing that. I think it just highlights spelling mistakes or things that it thinks should be changed, but I don't think it actually autocorrects them. I have to look into that and see if it actually does that.
Okay.
I bet in a different version of LaTeX, like if you were to download it on your own, you can probably configure settings like that, but I'm not sure with Overleaf.
Italic, it's like a new equation. Everything's
So
attached to
both,
italic.
whenever you see an italic, that's either been written by doing /it and then whatever you wanted in italics in squiggly brackets. If it's a part of a math equation, regardless if it was inline or display, it's always going to show up in italics. So if you do an inline or a display, I'm sorry?
Like how do they know this is an equation without you specifying it?
So if
Oh,
you
because
actually,
you have the
so
dollar
delete that dollar sign there and that dollar sign there. So what's going to happen is the deltas aren't going to be recognized. But if you scroll, you see, so it doesn't so you did slash delta, and so it says, oh, I think you meant to do math mode, but now it doesn't know where to end. So it's just going to do everything in math mode. And so you can see everything's going to be squiggly now.
Oh, okay.
So it knows where to put the math mode stuff through the dollar signs or with the begin and end.
Okay.
Yep. Okay, due to time constraints, if you finished or not, we're just going to move on. If you want to see the solution to the exercise, you can click here, or right-click there, I should say. You can copy this whole chunk, or you don't have to copy it, and you can play with it later. I'm just going to enter and recompile. So here's that exercise. I got the symbol new by typing /NU, and then I wanted a little 0 at the end, so I did an _0. Ignore CE. That's a special command that was supposed to be actually later. I meant to change that. This should be /text. Whoops. /text, etc. The CE is actually if you wanted to write chemical symbols. But so new was /new. I made my fractions by using the /frac and everything I wanted in the numerator, and then everything I wanted in the denominator. And then for the inline math mode things, I just encapsulated everything I want with dollar signs. Okay, great. The last thing I want to do before taking a break is show how to create tables. And we actually won't do the exercise for creating tables, but I just want to show at a high level, how do you create tables in LaTeX? How do you specify how many rows and columns? And how do you separate each element within the row? As well as writing captions for the table. So making tables in LaTeX can be a somewhat tedious task compared to Google Sheets or Excel. There are some excellent applications on the web you can use. So let's say you have an Excel spreadsheet. You can go to this link here, which is tableconvert.com. You can enter your table source and how you want it converted. So I don't have a CSV example. So it's a CSV, and I want my table to be, well, what was it here? Upload. Whoops. I forget how to use this because I actually don't use this that much. Oh, here we go. LaTeX. Close. Here, it'll actually generate a table for you if you have a CSV file written in LaTeX that you could just copy and paste directly into your LaTeX file. Similarly, if you use Python, like myself, there's a pandas tool used to convert all the things in the pandas data frame into a LaTeX table for you. We're not going to use those particular tools here. We're just going to make a table from scratch using the package Tablar X. So to begin a table, what you do is you initiate a begin table and an end table. What I'm doing here is I'm creating a new page just to make the document look clean and put the table on a different page. A section, I'm going to create a table that says make table, begin table. Ignore what this H is. I'll come back to that in a second. I want this table to be centered on the document, and I'm going to put a caption above the table. Generally, when you make captions, they go above tables, not below tables. And then here, begin tablar, is where I actually make my table. So here, I'm making a table with 3 columns. I know it's 3 columns because I have 3 letters in here. They could be C, which stands for center the element in the column, They could be L, which means justify it to the left, or they could be R, which means justify them to the right. These vertical lines here are going to tell me if I want to draw vertical lines along to separate each column. Then I'm going to add a horizontal line to my table. I'm going to fill my table with content. So each of these cells are the content that's going to go into the table. And each element in the table is being separated by an ampersand. And then when I'm ready to go to a new row in that table, I do 2 double slashes, and it takes me to the next row. So I'm just going to copy this here and play around with some of these parameters to show you what happens when you change them. So I'm going to hit recompile. So here's my little table down here. If I wanted to left justify these, the first cell, and right justify the the third cell, I could switch those 2 C's with an L and an R. And it's a little hard to tell here because the things are so small. Let's see, I'm just going to make this longer by just typing some I's. You can see here, these have been right justified. It's a little hard to tell, but these are center justified, and these are left justified. If I didn't want the vertical, let me switch these back to C's. C, C. Great. If I didn't want these vertical lines going through the table, I can delete them. So I'm going to delete these 2 lines here that are separating the 2 C's. And you notice those vertical lines went away. If I didn't want the vertical lines at the end of the table, I would get rid of these at the beginning and the end of the C's. And so now I have vertical lines going through the center, but not at the ends. If I didn't want a horizontal line in this table, I would get rid of H line. Instead of getting rid of it, I'm just going to comment it out. And you'll notice that horizontal line at the bottom of the table disappears. So you can control the lines in your table by using these vertical lines between the letters or horizontal lines. Similarly, as we did with equations, you can label your table so that you can use your table later in the text or refer to it later. And then once you're done with your table, you tell LaTeX that you're done centering, and then you end the table by doing /end table. Coming back up to this H, does anybody want to take a guess? Well, it's actually written here, so I won't say. This H controls where the table shows up in LaTeX. So if you did not put this option here, LaTeX is going to make its best guess as to where to put the table. If you want this table to show up in a very specific place, you would say bracket H, which means put the table here. If you wanted the table to show up at the bottom of the page, you would replace H with B. And you'll notice there's no table up here anymore. It's now here at the bottom. So you're overriding LaTeX's personal judgment as to where the table should go by giving it an option. You can give it several options. Those options are, where are those options? Oh, here they are. So you can give it the option T to force the table to go to the top, B to go to the bottom, or P, which is give this table its own personal page. All right. There is an exercise here, which we will skip just due to time constraints. Are there any questions about making tables or back with making equations? Yes?
Can you change the distance between the caption and the table?
That's a good question. Can you, so let me go back to the document. The question was, where is it? Let me change this back to H. So the question was, can you change the distance between this caption and the table? You can see it's a little smushed together. The short answer is yes, and I forget how to do that. I would have to look it up again, but there is a way to control the sort of vertical spacing. It's probably the command. I'm just going to test this to see if it works. /vspace to specify some vertical space. And then I'm going to give it, I don't know, 5 centimeters. Let's see what that does. I don't even know if this is going to work. Yeah. So you can adjust the spacing between the caption and the table by using that vspace command. Clearly 5 centimeters was too big, so you can just adjust those parameters as you need. That was a good question. Are there any other questions? Okay, so that was the first hour of the workshop. There is another section of this workshop that's going to cover slightly more advanced topics, such as, let me just go back to the beginning. So when we return from a little break, we'll take a vote on sort of which order we want to do this, if we want to discuss doing citations or figures first, as well as adding chemical formulas. But that's it for the first hour. If you have any questions, feel free to hang around for the last 10 minutes. If you need to go, feel free to go to class or other appointments you have. And when we return in about 10 minutes or so at 3:12, we'll start either adding citations or creating figures. All right, thanks.